Welcome you all. In this session, we are going to discuss about Intel 8085 architecture. Expected outcome. After successful completion of this session, the student could able to explain the functions of various blocks in 8085 microprocessor. 8085 microprocessor is an 8-bit general purpose microprocessor that can address 64 kilobytes of memory. It has 40 pins and use 5 volt for power. It can run at a maximum frequency of 3 MHz. The pins on chip can be grouped up into 6 groups. They are address bus, data bus, control and status signal, externally initiated signals, serial I/O ports. Various versions of 8085 microprocessors are There are several faster versions of 8085 microprocessor. They are 8085AH, 8085AH1 and 2. Here comes the architecture of 8085 microprocessor. So the various blocks associated with this are accumulator, temporary register, flag register, ALU, timing and control block, interrupt controller, serial I/O control block, instruction register, instruction decoder and machine cycle encoder, multiplexer, temporary register W and Z, general purpose registers B, C, D, E, H and L, stack pointer, program counter, incrementer or decrementer latch, address buffer and data buffer. So these are the blocks associated with 8085 microprocessor. First, let us discuss about the register session. There are three groups of registers. First one is temporary register, second one general purpose register, and the third one special purpose registers. Temporary registers W and Z are two 8-bit temporary registers used to hold 8-bit data or address during the execution of some instructions. These registers are not available for programmer, but 8085 uses these internally to hold the temporary data during the execution of some instruction. Say for example, these registers are used to store the intermediate data during the execution of certain instructions. General purpose registers D, C, D, E, H and L are used as general purpose registers. Each 8-bit long, they can work in pairs such as BC, DE, HL to store 16-bit data. The HL pair works as memory pointer. A memory pointer holds the address of a particular memory location. They can store 16-bit data address at the work in pairs. Second one is special purpose register. Accumulator, status or flag register, instruction register, program counter, stack pointer. These are all some special purpose register. Accumulator. The accumulator is an 8-bit register that is a part of arithmetic and logic unit. This register is used to store 8-bit data and to perform arithmetic and logical operations. The result of an operation is stored in accumulator. The accumulator is also identified as a register. It also works as a register for I/O access, that is, it reads data from input device and similarly can transfer data to output device. Second one is the status or flag register. The flag register is a group of flip-flops used to give the status of operation performed by ALU. The flag register is connected to ALU Once an operation is performed by ALU, the result is transferred on an internal data bus. The status of result will be stored in flip-flop. They are called 0, carry, sign, parity, and auxiliary carry flags. So they are bit addressable. The bit diagram for the flag register is shown below. Again, the flag register contains a number of flags either to indicate certain condition arising after arithmetic and logical operations or to control certain operations. The flag which indicates conditions are called as condition flag. The flag which is used to control certain operations are called as control flags. A flag is a flip-flop which is a set or reset by the processor to indicate certain conditions or set or reset by the programmer to control certain operations. Various flags are carry flag, auxiliary carry, zero, sign, and parity flag. So first, the carry flag. If the operation performed in ALU generates a carry from D7 to the next stage, then the carry flag will be setted. Else, it will be resetted as 0. Auxiliary carry. If an operation performed in auxiliary ALU generates a carry from lower nipple to the upper nipple, auxiliary carry flag will be setted or else it will be resetted as 0. Zero flag. If an operation performed in ALU results 0, value of either 8 bits, then 0 flag will be setted or else it will be resetted. Sign flag. If the most significant bit is equal to 0, then the number is positive, else it will be negative. So the final flag is parity flag. If the results consist of even number of ones, this flag will be set, or else if it is an odd number, then the flag will be resetted. Instruction register. Instruction register is an 8-bit register. Temporarily stores the operand of the instruction of the program to be executed next. Decoder then takes the instructions and decodes or interrupts the instruction. Decoded instruction is then passed to the next stage. Program counter. This is a 16-bit register. This register is a memory pointer. The microprocessors use this register to sequence the execution of instruction. The function of program counter is to point the memory address from which the next byte is to be fetched. When a byte is being fetched, the program counter is incremented by 1 to point out the next memory location. Stack pointer. Stack pointer is a 16-bit register which is used as memory pointer. A stack point is nothing but a position of random access memory. Stack pointer maintains the address of last byte that is entered into the stack. Each time when the data is loaded into the stack pointer will be decremented by 1. Similarly, it will be incremented when the data is retrieved. That is, if a push operation is performed, then the pointer will be decremented by 1. If a pop operation is performed, then it will be incremented by 1. That is the case. Next is ALU, Arithmetic and Logical Unit. The ALU performs the actual numerical and logical operations such as add, subtraction, and or etc. Use data from memory and accumulator to perform arithmetic and logical operations. Always stores the result in accumulator. Interrupt control. So here the interrupt control that controls or manages the interrupt occurred in the processor. Serial IO control group. The data transferred on the data bus is parallel data, but under some conditions it is advantage to use serial data transfer. At that time, the control group is brought into application. There are two instructions. There are two, that is serial IO data and serial output data. So, thank you.